My name is Etienne Bernard, and I work at Wolfram Research. I'm a lead architect. And today I'm going to talk about the advanced use of automatic machine learning functions. So these functions are automatic, as the name indicates, but you can also customize them a lot. And that's what I'm going to talk about today.
Hey everyone, thank you for being here. So I'm going to talk today about some advanced use of the automatic machine learning functions. So that might seem a little bit contradictory because they're automatic. So what would you use them in an advanced way? Well, it's because we try in this function to have a bit the possibility to use them as like full automatic mode, but also the possibility to customize them a lot by changing, I don't know, the preprocessing, the method, the hyperparameters, this sort of thing. That's one thing. And also, when you have the model that has been trained automatically, even if it's trained automatically, you can still do things with this model, such as measure how good it is, get information about it, or sometimes change the class priors or the utility. And this is something that is not about automating. It's your own utility. I will talk about that. So that's other thing that I don't see done a lot in practice. And that's why I'm giving this talk, to tell everyone, like, look, there's all these options, there's all these possibilities. You can use them and get the best out of this function. OK, so the automatic machine learning functions, I put here, there's many, I put here the main ones. So classify, predict, this is like supervised learning functions to do classification and regression. Learn distribution, this is a recent function we added, which is kind of the, very important function about unsupervised learning. It learns the distribution, and then with that you can do some applications such as synthesizing the missing values or finding the anomalies. Find clusters to find clusters, and dimension reduction to kind of find a representation, usually a numeric representation that is small for each example of data set. So it's kind of transforming a data set from something big, each example is big, to something where each example is small. A sort of compression, but anyway, let's not go into detail. So that's the main functions. I'm going to talk really about classify today, because that's the most used function. And actually, what I will talk, most of it can apply to about everything. Especially predict, learn distribution. Find cluster and dimension reduction, they use a different automation. We have to update them. They still use a bunch of heuristics. They're not super smart in the way they are automated. So some of the things won't apply to these two. Some will. But in any case, I think the richer function is classify. So, OK. So what is classify? And OK, I could say what predict is as well, but it's be the same thing. So classify, automatic function to learn a classifier. So this is a simple way to use it. You just give a data set. This means that when the input is 1, the output is A. Here, when the input is 2, the output is A. OK, so it's 4 examples in this data set. And when you run it, you might have seen some, monitor thing. Then it returns a classifier function. And then you can use that on new data. For example, I can say, OK, what is the class for 1.6? And say, OK, 1.6 is probably A. And I can also ask, how sure are you about it, by asking the probabilities. It will say, OK, these are toy examples. It doesn't really make sense, but it's like pretty damn confident it's A. I guess if I put something like 2.6, it's going to be a little bit less confident that it's A than B. OK, predict works the same way, but this time is for numeric output. So I can also do like on the predictor function, after training it, what is the value that you predict for the input 1.6? I can also say what is the distribution that you predict. What is the distribution of the prediction, basically, and that's it. All right, so now let's train that on images, and I'm going to use this example to show all this customization that I was talking about. So this is a data set with 20,000 images that have been tagged according to their label. So this is the 5, this is the 4, this is the 8. All right, so it's just to recognize and return digit. I ran Classify. And I'm going to explain a little bit what's going on as well here. So basically, it's trying a bunch of experiments. And I can see these experiments if I, OK. So for example, it gave 200 data points for the method logistic regression with these hyperparameters. And it gives 200 data points to logistic regression with hyperparameters. And that's the result. So by doing these experiments, it's trying to predict what is the best method and the best hyperparameters and so on for the full data set. So that's basically the automation that is inside. So you see that for now, only small experiments have been done, but some have probably been ruled out. So this one, I don't know which one it is. It's naive Bayes. Okay, naive Bayes apparently performs very bad on this small data set, so it's not going to be tested on the high data set. So that's kind of the essence of the automation. So now there's kind of 3 contender, and then you'll see that one or two is going to be trained on the full data set. And the advantage of this procedure is that you can obtain learning curves. So you see the learning curves here. It's what was the performance of the best model when it has been given this amount of data. And here, so that was the performance. Then you give more data and another performance. Sorry, it's a dynamic that problems. And you can see that, of course, the more data you give, the better the model perform overall. And which is actually pretty nice, this learning curve, because it can help you answer the question, should I try to give more data or not? And if you see like a sort of plateau, like maybe this is one, we have to see the end of the computation, then you might think, well, you never know if more data will help or not, but it's a good hint to look at this learning curve. And so you have this for the this is for the loss function, which is actually the likelihood. So okay, that's something I should say as well. This is the accuracy. Actually, I'm surprised. Normally it goes higher. I think it missed the best one. Let's see. Oh, I didn't train yet? Oh, I did. OK, nearest neighbor is the best. I wonder why. OK, I'm going to explain that, what's happening after. OK, so this is our classifier. And so the method logistic regression has been selected, which is a little bit surprising, but I will explain why after. And then you can use that on you. So let's do a test set. And so this is test data. You always test your model on data that hasn't been used for training. Let's do a random choice. All right, so this one, or one is not fun enough. OK, this 2, so hopefully it says it's a 2. Yep. OK, so to be working. And now I'm going to talk. It was a bit slow. I'm going to just use 10,000 examples from now on, because I'm going to do this computation many times. All right. So that was probabilities. All right. So first, let's talk about the high-level specification you can do. The first one, I think the most important one, is a time goal. So you can specify, actually, I want the training to just take 20 seconds. OK? And you can also, by doing control equal, specify any quantity. You can put minutes, days, and you can see here that then it's going to go much faster toward and spend way less time trying thousands of configuration on the lower training set side. Actually, here you go. Actually, it's already over. I also had less data, so it's a bad comparison. But OK, so very important. I think the most important option, actually. Performance goal, second most important option. This can allow you to tell the model what trade-off it should be doing. So if you put memory, for example, Classify will try to find a small model, right? If you put speed for performance goal, so let's for example do one. OK, so I could put time goal as well. Why not? And then I could put performance goal goes to memory. And here, so this is a loss function, but that's actually not what's selected in the end. In the end, it's something that is combination of the loss the speed of the model, the memory of the model, yeah, basically. And that's why before logistic regression was selected, because for some reason, I guess nearest neighbors were performing very bad in terms of memory or speed. But you can change that. So, okay, this one with memory, but I could also do quality. And quality won't care about the memory, won't care about the speed, or care very little. Like it's true, if you have something that takes 1 terabyte of memory, it might, penalize it. But so only go for the best prediction. So it's changing the internal utility function that is used to select the best model. All right, so that's the second most important option. Now let's go to the more lower level option. One is a method option. So you have a list of methods you can specify. Let's see, they are listed here: decision tree, gradient boosted tree, logistic regression, and so on. You can click on any of them, and they have their own documentation page that detail their hyperparameter, and I'm going to talk about that right now. So okay, that's how you specify, just generically use this method. But this over here, so let's stop it. Over here actually defines, okay, use logistic regression, but use the sort of sub-option L2 regularization and set it to 1. This is, in machine learning, you call that hyperparameters. Here it's basically a sub-option. Okay? And if we go to the page of logistic regression, we can see all the possible sub-options. So L1, let me put bigger for you. L1 regularization, L2 regularization, and optimization method. There's 3 possible sub-options, and that you can specify using this syntax. Okay, a list and then whatever you want, like option pattern after. So that would be okay. So that's one way to have a more low-level use of Classify. Another one is a preprocessor. So here, okay, I changed examples. Here I'm going, so I can use the option feature extractor to preprocess the data. So segmented words means, well, first, basically, extract the words from the data. That's what this means. And I can also put a pure function. This is just a pure function. So this was a named feature extractor that you can see in documentation. You have a bunch of feature extractors that are named, okay? But you can also put any pure function, and you can combine them as well. That's something like few people know. You can do a list and kind of say first do to uppercase, then do remove the diacritics, then use the segmented words feature extractor. Okay. Another thing that you can do is to do that in 2 steps. First, you extract the features. So using the feature extraction function. So here it is. Actually, we could do the full. We could do the full pipeline. All right. That's the feature extractor. And then I could extract the features, train the classifier. Okay. So you see here the input type is nominal sequence now. It's not text anymore because it has been extracted. Actually, it has been trained on this data. All right. That's the feature extracted, remove the diacritics, and put everything to uppercase. Sorry, yeah, uppercase, then remove the diacritic, then the words are extracted. But then what you can do is actually plug the feature extractor into your classifier by doing classify. First argument is a classifier, and then you put the feature extractor. And here you go. Now we have something that works on text again. So if I do C2 of the cat, it should say cat. Okay, that's some useful things. Sometimes you want to do often you want to do feature extraction on the side, then train, and then put everything back together. Okay, now let's see how you can control almost everything. There's a little bit of automation, but almost everything. So for that, you first have, as explained before, to fully specify the method option. So in the documentation, you just put a value for each of the sub-option, okay? Then the next thing you have to do in order to have full control of what's happening, so this is really when you want to, do research, or you don't trust the automation and you don't want to do your own business, okay? Or just to understand how the model works. That can be useful to get rid of all the funky behind the curtain thing happening. So one thing you have to do is set feature extractor to minimal, because as I was saying before, feature extractor is a pre-processing. So we will pre-process the data, but it doesn't replace the internal feature extractor. So you do some feature extraction, but then internally there's still the automation that says, oh, I see an image, I'm going to do this. I see text, I'm going to do that, blah, 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 blah. So with this, it's going to do the minimum it can. For example, if you put an image and you say train a logistic regression, feature extractor of minimal, it's still going to transform the image into a vector. It has to, otherwise it just doesn't work. But it won't use a neural network to do that. It's like the simplest possible pre-processing that it does. So that's.
You would do that for speed?
You could. You could. If, for example, for some reason the default feature extractor will take time, or sometimes you know that no feature extraction is needed.
Like if you already had an array of numbers to start out with, it probably wouldn't mess with that.
Yeah, I mean, it might standardize it automatically, and you know that you shouldn't standardize and do nothing. You know, logistic regression on these numbers will work very well.
Yeah.
It happens, so you can do that. And okay, so the second thing is to put performance goal direct training. This, because you saw here, it's still doing, actually, even if I specify everything, well, whatever. Actually, in that case, even if I specify everything, it's still going to do a learning curve. And this is because even though there's only one, you see, there's only one experiment that is done. But so we already know which configuration we're going to try on a full data set. But having a learning curve is also nice for, as I was explaining before, to know if you are improving or not. So that's why it does it by default. But if you want to remove the learning curve, you do direct training. And here, it just doesn't do any learning curve. It just train on. So in that case, it will train with a random configuration. But if you specify, it will train on the configuration you want. And so if you put everything together, then you have full control. Here, you're guaranteed that there's nothing, no preprocessing, no weird preprocessing, no automation, no feature extraction. Yeah, exactly. And here you go. That can be used for benchmarking, for example. If you want to benchmark, sometime I receive an email say, oh, your logistic regression is slower than something else. You cannot really compare when it's doing a full learning curve. But when you're doing something like this, you can definitely compare, apple to apple with some other thing. All right, that's how to get full control. Okay, now this is basically what you need to know for training. That's all the tricks there is for training. Now I'm going to talk about more, tricks for understanding what your model is. So one thing is to use information, and that's really, oh, okay, I know. Oh god, that's weird. Well, let's just train this one, and let's do, actually not this one. It's going to be less fun. I'm going to train one that has. Okay, I'm just going to train one that has a full automation. It's going to be more interesting. Hopefully it's faster now. All right, 5 minutes. So, okay. So information is kind of the main function to, as the name indicates, obtain information about the model. So things like, that's accuracy with its uncertainty. That's a method. There's a lot of information that you have by just hovering the mouse. A lot of tooltips. So for example, here you can see that its neighbor's number is 10. The distribution boosting is 0.5. That's the nearest method is scan. You can have things about the evaluation time on your computer. Okay, that's interesting. This is computed when you call information. So you see here, it's 3.4 milliseconds, per example. But if I do it again, it might be a little bit different, like 3.39 here. So if you give this classifier to, I don't know, a server that's going to run it or whatever, it's kind of benchmarking its speed. You can obtain the speed by doing information. Okay, and some other information. You can see the learning curve. You can see all the experiments. You can, okay, that's useful to actually look at maybe, like this one. This logic regression. You might say, well, me, I think that this one could have performed good. So let's grab this hyperparameter, and then you put that as a method option into Classify, and you can, so it's an interaction between you and the automation and you. That's why I like to be a bit transparent about what's happening under the hood. You can ask things like mean course entropy with information, and actually that's all the properties you can ask, at least for this model. So I can also ask nearest neighbors numbers, like some of the hyperparameters. One useful thing is method option, because this is the method. It's the configuration that has been selected by the automation. So then, if let's say I get more data, right? I train something, and now I have twice the amount of data. Well, it's likely that the best configuration is going to be the same. So I would put my new data and just use the same configuration that has been found before, and this is going to be much faster. Actually, if I retrain on that, sorry, it's Classify. And if I put direct training, for example, because now, let's say I don't care about the learning curve. Performance goal, direct training. This is going to be much faster. So that's a good trick. I think this is a super good trick. Okay. Okay, still I don't have much time, but anyway, this is some internal information. Let me see if there was something more important. Oh, there was a lot of things I wanted to talk about. Okay, very quickly, that's a classifier. If you look at, you kind of do first on the classifier, see what's inside. This is completely non-documented, but you can see everything that is inside. So, the preprocessors, usually their name, it's self-explanatory, like conform image, and you understand what it is. So this can be useful if you understand what's under the hood. You can see, all the configuration that have been tested. You can convince yourself that this one is the best, by looking at, okay, with a training size of 15, that was the accuracy, it was a mean course entropy, blah, blah, blah. With a size of 1,500, this was a result. And anyway, this is really if you want to do advanced thing, but you can go in, usually you can understand what's going on, understand how the automation works. And actually, this is not documented, but if you want, you can use what we use internally to preprocess the data. So basically, the idea is to first convert this to what we call ML dataset, and then you can create processors, like standardize. Anyway, there's some interesting what's going on. Okay. Oh, I put on the preprocessor. Okay. And it gives a new processor, and and the resulting data. Anyway, it's kind of internally documented, so you can look. I know people use it; they like it. Hopefully, we can make that top level at some point. So that's something. Okay, measurements. Okay, very quickly, we have something called classifier measurements, right? And I just want to tell the properties. So you give it the classifier as a first argument and the test set as a second argument. And then you can ask a bunch of properties, such as accuracy baseline. I mean, there's a bunch of things. Here, I want to tell what I think are important. So, for example, you could have a report. This gives you a bunch of information, including confusion matrix. You can ask for the confusion matrix as well, and you can also restrict it. This is confusion matrix restricted to these three things. But more interestingly, this is a confusion matrix restricted to the class that are the most confused. So apparently 1 and 7 in this model are the most confused class. You can also ask for top confusion. So typically 4 are confused as a 9, 2 are confused as a 7, okay? You can also have the worst classified example. So that's the example that are badly classified, which often help you clean your data set or improve the model. So anyway, I think that's important properties.
I may have to stop you there. We do have to switch to the next speaker. So thank you. Sorry.
Okay, maybe we can wait that the speaker arrives.
I'm sorry?
Is he here? Oh, it's you, Sheta? All right, let's continue. Let's continue for 3 minutes. We can do a quick transition. Okay, so class priors. Okay, this I want to say because that's, I think, underused things. It's that every model is probabilistic. They don't just give a decision, they give probabilities. And this is super useful because you can, of course, know if the decision, if it's confident decision or not. And one thing you can do is change the class priors after you train. So you can train on your data, but then you might say, OK, on your test data, I know that 50% of the time it's a 9. So I will change the class prior like this. OK? And then it's going to be better because it has this extra prior information. And here is how you would obtain the class priors. And you see that now 9 is 0.5. Another thing is indeterminate threshold, which is basically if the probability doesn't reach this threshold, say indeterminate. So if we do something like this, and OK, and test is 0, probably it will say indeterminate because I put a very high threshold. Actually, no. So let's, oh, it's C2.
Question.
Yeah, indeterminate. Yep.
Why wouldn't it do that on its own for the classes? Why wouldn't it say, well, what's the most frequent, what are the probabilities of each class?
It does it, but with the training data. But if your test data is different to your training data, it cannot do it. So if in practice, you run your model on some data that have a different distribution, then you can do that. All right, utility function, I'm going to finish with this. It's basically a way to specify. Actually, I would prefer you to, I really don't want you to misclassify a 4 as a 9, for example. And you can do that by changing the utility function. So the best is to take the default utility function, which is this one. And then you can, oops, sorry. Where am I? Then you can do classify again. And you put the classifier. And then you say utility function. And I'm going to change it. And for example, OK, I don't want a 0 to be classified as a 7. So I'm going to put minus 0.3 or minus 0.5 here. And I just changed the utility function. That's useful. For example, you don't want, I don't know, a mushroom to be classified. You prefer a mushroom to be wrongly classified as poisonous than wrongly classified as edible. That's a classic thing. All right, and maybe a last thing is that if you want to export import, you can use a WMLF format, and you just use export import. And that's it. Thanks.